let's go on to control by alternators. Now let's look at the equivalent circuit of an alternator again quickly. Here we have E angle delta is equal to V angle 0 plus IA angle plus or minus phi times ZS angle beta. And the phasor diagram with V as a reference and the current lagging by an angle phi. Then we have IR and IX, and that gives us the induced EMF. And that angle there is known as the load angle. And that is IAZS. Okay, let's say we change the excitation come again by 20%. So that means E2 is now 1,2 E1. Now if we look at the phasor diagram again, let's say we ignore R. That will be IA. IXS, V, and E. Now, the line perpendicular through the tip of E is called the power line. And that is 1 per unit power. So if we now increase E by, let's say, that amount, and the power remains the same, that means this induced EMF is going down until it touches the 1 per unit power again. And that means our load angle 2 is less than the first load angle. Let's look at a numerical example. Let's say we have XS is equal to J 1,7241 per unit. The current that this alternator is supplying is 0,8 at a power factor of 0,9 lagging. First of all, we have to determine the induced EMF and then the power and the reactive power that the machine supplies. So V is our reference, which is 1 angle 0, and therefore E angle delta is V angle 0 plus IX 90 plus or minus 25,84. In our case it will be minus because it's lagging, and therefore that will be 1 angle 0 plus 0.8 times 1,7241 angle 90 minus 25,84, which gives us 2,0261 at an angle of 37,8 degrees. And the developed power, or the output power, is E V over X sine delta. In this case, it will be 2,0261 divided by 1,7241 sine 37,8, and that gives us a value of 0,72 per unit. And the reactive power Q will be V over XD E cos delta minus 1 or minus V, and that will be 1 over 1,7241 and that's 2,0261 cos 37,8 minus 1, and that gives us 0,3487 I'm going to write it here, 0,3487. Now let's say we increase the excitation. E2 is 1,2 E1. P1 remains the same as P2. So we don't change any power of the machine. So therefore we can say that E1 V1 over X sine delta 2 will be equal to 0.072. And if we calculate delta 2, we find that it is 30,7 degrees. And now we can calculate Q2, which is 1 over 1,7241, 1,2 times 2,0261 cos of 30,7 minus 1, and that gives us 0,6325 per unit. And therefore, the percentage change in Q was 0,6325. What was Q1? 0.3487 minus 0,3487 divided by 0,3487. So here you can see that by changing the excitation, Q changes. Now let's look at the case where we increase the steam input. To the alternator. Now in this case, if we increase the steam input, the load angle is going to change. So increase in steam is directly proportional to our load angle. Now let's say we increase the steam input so that the new load angle is now 45 degrees. What is going to change? Sorry. P2 is going to be EV over X sine delta. So that will be 2,0261 divided by 1,7421 cos of 45. That gives us a power of 0,831 per unit. Q will be 1 over, or V over, X E cos delta minus V. That is 1 over 1,724 angle 2,026 cos 45 minus 1. And that gives us a value of 0,251 per unit. You don't have to write this down. Let's change it to sine, if that makes you happier. That was just a misprint. Okay. So where can we see here changing the steam input? The biggest change is in the real power. Okay, let's look at some examples. Okay, Dean. Thanks. All right, you got this. You can look at it again on YouTube until you're sick of it or until you understand it. You got it? I don't think so.